Hello to everyone. My name is Yerjan Uzakbayev. I am geologist and I'm representing DataMine UK office today. Today I'm going to show you our one of our models is we call Advanced Geostats module. And before to start, actually, I would like to say that how it's going to be. I'm going to run the webinar. Then at the end of this webinar, we will have, let's say, 3-4 minutes for the question answer session. And also today I would like to introduce my colleague. We will be together with my colleague. His name is Paulo Diaz. He's our geostatistician. Also, he based in UK. And then you guys please take that opportunity that he is with us. And then if you have any question which relate with the geostatistics or anything what you can see today, and you can ask after that webinar. Okay. Okay, let me start our webinar. Just a little history of that Advanced Geostats module. Actually, this is the one of the product with collaboration with the GeoVariance company. Okay, and then let me start to show you that with the Advanced Geostats model. Advanced Geostats model you can find under the estimate. You can find here the multivariate. That actually model requires separate license. But you can run via Studio RM. Okay, what we can see here, this is our menu, and then you can see here this kind of workflow from top to the bottom. If you have a look, we can see what we should do step by step, and then to reach that that level where we're going to estimate our block model. Okay. There's a lot of people ask me like if it's kind of, if there's a similarity, if for example person wants to estimate block model or do the variography or do statistical analysis in Studio RM. Yes, they are actually the both way. You can do either if you want to estimate your block model, and then you can do via Advanced Geostats model, or you can do via Studio RM. But only one exception here, that in Advanced Geostats model allows you to use Kriging neighborhood analysis, which allows you to define the optimal parameters of estimation. We're going to discuss about this later today. I'm going to go through and then show you this. Okay, and then let's start. Here you can see that we have a scenario. The first item here is scenario. What it does and what we can do with this. We can see here that I already have a scenario which I, let's say, created before. I can create a new scenario. If I click here, create new scenario, I give a name, let's say run. Let me put 1 because I don't have 1 here. Run 1, save changes. And then you can see here run 4, run 5, run 6, and then how it works. For example, I'm going to estimate my block model with the data which is available for today. And then for in a case if I need to go back, and then let's say I have a set of data which is I received, let's say 2016 or 2018, and then all those scenario I can save it. For example, if I created the block model and estimated in 2000, let's say a year ago, and then in this case I can go back to here, and then after that load selected, then after that I can see all the parameters that I applied, and then after that I can do comparison what I have at the moment, what I did before, and so on like this. This is the how it works, the scenario. Or another good example to use scenarios that, for example, if you apply the one, let's say, approach in terms of the method of estimation for your project. Let's say you can save as a one scenario, right? Is let's say you apply the ordinary kriging or co-kriging, but for another scenario you want to apply, let's say, just IPD or nearest neighbor. Then after that, you can all those scenarios you can save it, yeah. And then the good thing is here that you can always get back to the scenario, and also you can export scenario and you import scenario. For example, if I created the scenario here with my all step of my block model estimation, then after that I can share with my colleague, and then that my colleague can just import that scenario, and then he can run everything what I've done on his machine. Okay, this is how it works. The next one, if I go back to here, select samples. Here I have to select the samples which I'm going to use for the estimation. Let me select my samples, holes EG2. Yeah, and now we can see X, Y, Z, that's fine. And then here the selection list. Here I have to select the variable which I'm going to use for the estimation, for variography, for the kriging neighborhood analysis, and so on like this. In this case, I'm going to use my silver, gold, copper. And also, if you have a look here, we have a zone 1, zone 2. What is this? This is kind of key field which you're going to use. Let's say my project, let's say my this data set, it's has a, let's say, the grid has a zone control. The key field, for example, I can click rock, and now you can see the system split up my samples by a rock key field by that zone. You can, if you want, you can call the main, and then here you can see 0 zone, 1, 2, 3, and then also number of samples, what we can see here, and also we can see number of holes for each zone, and also we have range distance, mean length, and so like this. Okay, this is kind of summary of your samples. The system automatically calculate for you, but also if I click here the calculate distance statistics, if I click here, there's also the system now is calculating the distance between samples, the mean distance between samples, and maximum distance between samples, as you can see here. Yeah, the maximum, for example, for zone 0 is 881, the mean is 330, the minimum distance 41 meters, and so on like this. Okay. Another thing, please pay attention here. On the right hand side, you can see the sample statistics. If I click here, recalculate sample stats. If I click here, yeah, the system split up the zone selection by my key field, by my zone 0, 1, 2, 3, and then also you can see here 0, 1, 2, 3 as well. And then I can selecting here, I can see for each zone separately statistics. Okay. For example, for zone number 1, it's where the most of the samples there. I mean, like a lot of samples, more than 3,000 samples there. I'm going to use it today as the main one. And then here, if you click here, the statistics, we have options here. The correlation matrix is going to calculate for you correlation p-value, covariance, f-ratio, pair, t-test statistics. All those statistical value you can calculate, you can see. For example, let me show you the correlation one, correlation matrix. If you click here, the system automatically calculated and then created a correlation matrix where you can see dependence gold against the silver, right? And then if we have a correlation between them, between two variables. In this case, we can see that between two grades. In this case, we can see we have a 0.62 value of correlation. The maximum value of correlation, as you know, it's 1, and also it can be -1 as well, is -1 as well. If we're talking about the negative correlation, right? Now we're talking about the positive correlation, and a 0.62. And also that box is light up as a green box, and then which give us kind of indication that okay, there is a correlation. I cannot say that there's very strong correlation here, but yeah, there is correlation. If compare, for example, copper and silver or copper and gold, we can see here the 0.52, right? Slightly less. And the same way, if I go to here now, if I go click here 2, this is for number 2. Oh, sorry, for zone number 2, and then this is for zone number 3. Yeah, for zone number 3, that correlation between silver and gold is slightly less. Yeah. Let's go for next one. Move on. Next one, I'm going to show you here that investigate anisotropy. If I click here, anisotropy, here first thing what we can do here under the variography menu, the first one is the investigate anisotropy. This is variogram map, but this is variogram map you can do in 3 directions, and also it gives you the opportunity to see in a 3D as well. I will show you how it works. Let me select here the zone number 1, and then here my variable, I can use my gold. And then here, the maximum distance between samples, the system automatically calculated for us. It's just to give you the kind of idea. When you select the luck here, this gives you the idea about the maximum distance between samples, right? It's the it's something like when we choose the luck, it gives you some idea about this. Yeah, but when we reach that level of that stage of your project, of your resource estimation project, we usually know very well about the drill hole grid, about your distance between samples, and so on like this, about your dispersion of your grade, and so on like this. In this case, luck, I'm going to use, just pay attention here. By default, is also, I received a few questions recently about this as well. The maximum distance is 922. You cannot change it. This is not editable. It gives you that value. But the maximum luck and luck distance you can change. Usually, the maximum luck, this is the half of the maximum distance by default. Okay, is a 4061 is a half of 922 approximately, and then the luck distance is at like a 10% of the maximum luck usually by default. Okay. Now I'm going to change it. Let me put here, let's say 25. The maximum luck, let's put here the maximum what I'm looking for to define the correlation between samples for that data. Let me put 200 meters. Yeah, the number of logs 50. I'm going to use it. This is for mostly for the visualization, because of when we're going to create variogram map. We can see this is as a block model actually. Yeah, that's why we're talking about the blocks here. Sometimes we need to increase, sometimes we need to decrease the number of blocks. Yeah, it depends on the visualization of your variogram map. If I click here, creating 3D map, yeah, now we can see here, let me put somewhere here. Now we can see the 3 directions, and also we can see in 3D view as well here on the top to the right. Yeah, here. And here we can see that 3 circles which represent axis 1, this is Z, axis 2, this is my X, and then axis 3, this is my Y. And also, please pay attention here that it's, for example, that axis Z, that circle actually has a red line here, and then axis 2 has green line here, and then axis 3, this tertiary direction has color blue. Why we need this one? Once you arrange once you define your long direction, your short direction, your plunge, and then after that, if you want to have a look in 3D, it gives you kind of indication here that okay, this is circle shows that this is relates with the Z direction, this is relates with the tertiary direction, this is my secondary direction. This is for the visualization as well. Okay, that color. Now Let's have a look. Let's see what we can do here. If you rotate using your cursor, a left button, you can rotate and can define the best direction which represent your long continuity of your minimization. What we can see here, blue color, green color, and also we have red color. If you have a look, show the legend, it shows that this is your variance of your data, right? It's kind of variogram. Everything which is blue, that means like everything with above my seal, where there's no correlation between samples, no continuity. Here, the green color represent the correlation close to the seal, right? That means there is correlation, but close to the seal. And also we have a red color here. The red color represents high continuity, right? High continuity. The variance from by default from 0 to 0.7 actually. Yeah, from red high continuity up to seal by default from 0.7 up to 1, and everything higher than 1 is represented as blue color. But this is by default. But you can change, of course. You can change like this using my cursor, and then I can change it. Now I can see my high continuity. Now I increase. Yeah, now I can see much clearly and better here. And now I'm going to arrange my strike, my Z direction, and now I can see like this, I rotated 310 degree, and now I can see my long continuity that way. And also for the second direction, I can see my continuity as well, and my third as well. The only one thing I would like to say and mention here that it's quite like very nice and then very useful when you do the, let's say, variography study. When you rotate, for example, second directions, you can see, because all of them related, all of them connected. That's why, like, you can see how changing. For example, if you're changing the angle by X direction, I can see what's going on with my Z directions, and so on like this. Yeah. Ideally, of course, as you know, you should arrange the angle that would be suitable for all directions, yeah, to define that, say, the long continuity, short continuity, or for each direction, okay? And also you can see here, you can see your drill holes, my drill holes with what I loaded in my 3D window, and also I can see my variogram map here. Yeah, and now you can see I can check. If I check here, you can see my in 3D is everything is moving there as well. Yeah, let's use that 305 or 310 my angle, but also what you can do, either you can change here, or for example, you already know, your deposit, you already know that your azimuth and dip of your minimization of your ore body, you can type yourself here. Just type from your keyboard, click here and then type. Let's say for example 310, enter. Yeah, let me put it back. Yeah, 314. Yeah, and then after that, what you can do as well here, here we can see the auto fit as well. If I click auto fit, the system automatically fit your variogram map. Yeah, and then center variogram. Sometimes if you need to move your variogram map, I mean like the center of the variogram, if you need to move, let's say to define, let's say like some structures, what you can see, you can also move it as well, and then you can try to find the correlation as well. Okay, this is clear, is a 310, that's fine. Then after that, what I'm going to do, I've done my variogram map. If I go back to my my variography here, then if I click here now, create variograms, here that system, the next step, the system gives me the option to select the variables, variable for variograms. I'm going to select silver, gold, copper, all my 3 variables. Then also I have options here that downhole, I'm going to calculate the downhole variogram, I'm going to calculate cross variogram and directional variogram. Yes. The good thing is here, when I select all of them, there's the system in one run calculate for all type of variograms. Then after that, I can use them. The one thing I want to say about maybe some of you already know about this, and maybe for some of you it's new. This is that this type of variogram is a cross variogram. That cross variogram, what we have here, we calculate especially for Cochran method of interpolation. Okay, you can do it here. If I simplify, what is this? Is if you have a let's say if you have a correlation between two variables, between gold and silver, for example, and then you can use both variables to calculate the cross variogram. Yeah, to calculate the variogram. Now, I want to say something about the transforming of our data is a normal score function.
Yeah,
I would like to check. I would like to check with my colleague.
Yeah. It's important for now to mention that new functionality we have, because we include that function, consider our clients' requests, because usually they are working with such a high skill distribution, and it's quite common to have very unstable variograms. So we can approach this problem using a theoretical consistent procedure. Basically, what we do in this case, we are going to transform the data into a normal score distribution, modeling the variogram, and then back transforming not only the experimental values but also the model. So instead of just modeling the normal score, which will give you probably a more continuous variogram than the original samples, we have now the options to back transform the values, the experimental values, and also the model. So it's a really robust and consistent approach. Of course, many people use other approaches. For example, they can use capping, they can use correlograms, indicator variograms to have some insights, or even normal score without back transforming that. So it's a quite interesting functionality that can help a lot when you are working with this kind of unstable variograms.
Okay. Yeah, thank you very much for clarification, guys. It's the background of this voice was as I mentioned, Paulo Diaz, our geostatistician. We will come back to transformation of data. I mean, like, if you have any question, yes, we can discuss about this, and then I will also go through the other parameters, other let's say the items here. Then we will ask, I will ask actually Paulo to give his comment as an expert of geostatistics. Okay, thank you, Paulo.
No problem.
Okay, then next one, we have the variogram, like downhole, cross variogram, directional variograms. Let me run it. Then after that, what we have here as well, we have a reference plan rotation. That means, like, I'm going to use from that angle what I defined from my variogram map, I'm going to use to calculate my variogram. How we can do it here? If I click here, read from 3D map, the system automatically read actually that angles what I have in here, and then put it here. Okay, then I'm going to use it now. Then after that, here, this nice one, the horizontal direction, we can arrange the number of direction horizontally to calculate my variograms, number of direction vertically to calculate my variograms, and so on like this. It's quite nice and then useful because of as you maybe know, and we have a VGram process in a StudioRM, but they're like just settings, like you can just put the numbers, that's it. But here, the good thing is here, for example, if you change here the number of directions, you can see like interactively which direction it's going to be, and then it's which direction going to calculate. It's quite nice. For example, if I increase my tolerance angle 45 degree, I can increase. If I decrease my like this and so like this. Yeah, if I put here, let's say 10 and so on, like that way. Yeah. Yeah. Let me put two directions for horizontally, and also we have vertically as well. I'm going to use 2 is enough. Then after that, what we can see here as well, we can see the maximum distance for variogram calculations, 945. Yeah, we can also, that one valuable I can change. For example, I can put here 500 and so like this. It's editable. You can change it. Yeah, I think 500 would be enough. It's okay. Then after that is here, there's options here. You can also use cylindric radius as well. It's the same option what we have in our vgram process. Yeah, and also you can use the cylindric radius to calculate your variogram applying the cylinder. Yeah. If I click here now, select zone number 1. I don't want to select all of them. It's because otherwise it takes time. I'm select only one zone, and then I'm going to calculate all the variables, all type of variograms. If I click calculate variograms, yeah, yeah, it's done now. Okay, it's done now. We calculated variograms for 3 variables here. Then after that, what I'm going to do next one is fit models. If I go to the fit models, I want to say here, the first, you have a list of the variograms, what you can see here, and also pay attention here, we have azimuth and dip, but also we have world azimuth and dip as well. As we remember, because I have used here angle from my variogram map, that's why like it's considered here, and then you can see here in the world azimuth variogram, or world azimuth and the world dip as well. Okay. I just want to say that if you see here azimuth 0, it doesn't mean that 0. The mean is like 314 degree of azimuth of that variogram. Okay. Then from that list, you can display like this. If you click here, display. If I click, for example, one of the variogram, let me say, if I untick this, if I click only gold, now that one, which is the first one from the top with no angles, it always represents here the omnidirectional variograms. Okay, this is automatically calculates. Then if I go to the next one, this is my directional variograms. If I select perpendicular directional variograms, if I click here, now I have my directional variograms. Yeah. And also another thing is here, I would like to say that it's quite nice when you select your variograms and then select your variables for gold, then you can see here your 3 variograms. Then after that, what you can do, there's options minimum lag distance. You can change the lag dynamically here, yeah, just using your cursor from left to the right, and then you can change the lag, and then you can find what is the best lag to use for to create the model. Okay. Another thing which is I want to say as well here, you can apply the different lag, for example, for different directions easily, like this. If I click here, and then here's the highlighted directions. For example, for that direction, I'm going to 90 degree down. I'm going to apply one lag like this. Yeah, 39 meters. For that one, I'm going to apply, let's say, 46 one. And then for the third one, for that lag with my long continuity, I'm going to apply the different lag as well, 30, for example. It's possible, and then it can be done like these highlighted directions. Okay, guys. What else I would like to say here? If I go now here, if I would like to see my downhole varograms as well. To define the nugget, we need the downhole varograms, right? Then if I click here, display downhole varograms, then if I untick this, yeah, then this downhole variogram, it says downhole directionless. This is your downhole variogram, that one. Yeah, that variogram, which is here. Downhole, it says yes, this is your downhole variogram. And also it's, you can adjust the log, then after that you can define your nugget, right, that way. Okay, then I will remove now downhole variogram. I use my 3 variograms here. Another thing what I would like to say here as well, I can select the same way copper. Yeah, I can see that for copper variograms and for silver separately, individually. But I would like to use here today the cross variogram. I would like to use silver and gold because we had a correlation between them. That's why like I'm going to use the cross variogram here. I'm going to calculate the cross variograms, and then I've done it. Then after that, if I click here, run after fitting, the system automatically fit the variogram. It's the automatic one. It's, you should understand that it's the more average, right? As we usually use the manual fit. If you need to do some adjustment, if you want to use any some changes here, right, of your structure points, then after that, what you can do, there's options manual fit as well. If you can select number of structures, how many points you need to do the model. Then after that, if you click manual fit, if I click now manual fit, then after that I can do manual as well. Yeah. And also if I go back to here, format, and now you can see the display variance. This is my seal. It shows here my seal. I can normalize my variogram as well. Then after that, I have here display number of pairs. If I click display number of pairs, the system shows the number of pairs here. Then what else here? The minimum number of pairs you can be arranged here. I mean, like, for example, if you need to exclude some points with less than, let's say, 100 points, you can just type here 100 points, and then you're going to exclude the points here. For example, it says here 110 dead points. I can put here 112, and now this is excluded. Yeah. Okay. This is my variogram. Then let's leave it like this. Is it okay for now? Then after that, what I'm going to do, if I go to here under the save models, here I can save it my variograms. But before this one, let me just quickly show you here what we can see here as well. If I go to model parameters, you can see the parameters of your 3 structures, X, Y, and Z directions. This is your ranges. You can see from here as well. Yeah. Yeah, then if I go to here, the save models now, and what I'm going to do, I'm going to click here, create candidate model from set from display. If I click here now, the system save this file here. Yeah, then after that, what I'm going to do, then if I click here, I can use this as a candidate, which I'm going to use for the estimation or for creating neighborhood analysis. I can say here, commit to QKNA. Yeah, and then it's here. I can do another thing for you guys. If I just let me change the slightly my lock here. Yeah, let me go for now. If I click here, run after fitting again. Let me do just one more, please here. One moment, please. It's loading.
Jurgen, to take this opportunity, I think it's wise to mention that it's a new algorithm for calculating these variograms. And we are, in this case, we are calculating the variogram for all samples, all pairs. and then you don't have to recalculate the variogram for if you want to choose a new leg. So you can interact more and save time in the modeling process with this new tool. I think it's wise just to mention that.
Yeah, that's great. Yeah, that's great. I think it's I loaded a few RMs now. Maybe I can close this to make easy my oops. Yeah, this is because I closed my previous one. Let me load my 1 sec, please. Just let me load my previous. Moment, please, guys. Yeah. Yeah. Then if I go back to here is 8. Yeah. Then if I go to here my diagrams again. Yeah, it's let me say, yeah, that's fine. That's fine. Let me leave it like this for now. This is my variograms. Then after that, what I'm going to do, I save it for that variogram. Then the next one after this, I can do as well for copper as well. If I click here, copper, and then I do the auto fitting again, run after fitting. Yeah, I've done it fitting for copper, and also I can save it as well. Yeah, this is for copper, and then click here, and then here commit to QKNA. Done it. Then once I finish this, the next one, I'm going to go for the Kriging neighborhood analysis, which allows me to choose 3 points, 3 areas in my deposit where I'm going to define the optimal parameters of estimation. I have 2 variograms here. This is what I created. This is the gold and silver, the cross variogram, and also I have a copper one as well. Then how I can do the selection of the area? Okay, if I click here in my deposit, I have, let's say, well-informed area, moderately informed area, and then sparse area. Yeah, and then you should select like this. Click here, well-informed area, select that arrow here. Then after that, if you go to here in your deposit, and then select, for example, that point. Yeah, I selected, right click and selected. Okay, that means I'm going to test that area with a lot of samples, a lot of data. The second one, model informed area, I'm going to select here. Let me say something here, that area. And then with poor area with not so much samples, I'm going to select, let me say, that area. Okay. Then when I'm selected these 3 areas, you can see the coordinates of that area. I'm going to generate the blocks for each area. Is in this case 81 blocks around that point is going to be generated. Then after that, based on those blocks, the Kriging neighborhood analysis do the test. Yeah. This is fine, and also there's options here defined from prototype. If you already have the block model, and then you can load the block model, and then the system takes the parameters of the block model automatically, or you can use by default as it is. For example, you can do yourself 111. You can put it here and so on. In my case, I already have a block model. That's why the parameters is taken here. The next one is optimize. When I do the optimization, the first one is the optimize discretization points, one of the parameters which we need to do to run the estimation. I'm doing the optimization of discretization points. How it works? If I click here, yeah, then if I click 10 and 1, if I click run test, and then if I click here, average, This is average time, and then block covariance. And now you can see. Now I'm testing, for example, for the X direction, how many number of points we need to achieve good estimation based on block covariance. As you can see here, the system represents here that like if I use 1 point, 2 point, 3 point, 4 point, and then up to 4 points, yeah, that then up to 4 points, the estimation can be changed. It would be different, but up to after 4 points, and then my actually curve stabilized here. That means if I use 4 points, if my colleague will use 6 points, but the result of the outcome of the estimation would be quite similar, as you can see here. But my colleague will spend more time, let's say more time to run the estimation, and then but the result would be the same like mine, but I spent less time. Yeah, and also there's a nice graph here, average time per block. As you can see, for example, 4 points, it's here. But if, for example, if someone decided to use 8 points, is actually in terms of the time is double, right? He should spend, if I spend 1 hour, he should spend, let's say, 2 hours for that. Yeah, this is kind of graph. It's the same I can do for Y direction as well. And then let me just go back to my block covariance, and then I can do for Y directions. Let me put here 10. Yeah, then if I click here, run test. Yeah, if I click here, Y directions, and for Y direction, more or less a similar result. Yeah, the 4 points is the optimum number of points, distribution points for Y direction. Okay, and so like this. Then after this one, there's a block size, optimized block size. I already run it. As you can see here, now I'm checking here the block size for each direction, for this by X direction, and also on the top you can see well-informed area, moderately informed area, and the sparse area. Yeah, the 3 areas what I used. Yeah, and now I can see the 3 graphs here. For in this case, how we can read that graph? You can see here that graph built based on the kriging efficiency and then block size here by X direction. Then the highest kriging efficiency value represents the good quality of your estimation. Yeah, that means like in this case, the highest one probably here somewhere like 40 meters each. Then in this case, you can consider from 20 meters up to 60 meters is kind of optimum block size by X direction. Okay. And also we have I can do it for the Y, for Z as well, but also pay attention here that we have a measured value here. We have a lot of different statistical values here, which you can do as well. We usually, when we do the Kriging neighborhood analysis, we usually use the common one is the Kriging efficiency, of course, and then slope of regression, and also weight of mean as well. Yeah, the weight of mean, and also we have a slope of regression as well. Yeah, I think I need to give a word to Paulo. Maybe he can give some comments.
We have many parameters there. So, but I don't know how familiar you are with KNA, but basically we consider these 3 parameters. Yerjan have said the slope of regression is a good indication of conditional bias. So the closer to 1 it gets, the better it is. And the other parameter we usually use is the weight of the mean for simple kriging. It's better if it's close to 0, basically. So with these 3 parameters, consider these 3 parameters and varying these points Yerjan had selected before, you can have a criteria for defining your search parameters that we are going to see in the next step. But basically, we in KNA we are looking for the highest slope and the lowest weight of the mean for simple kriging. Basically, is that.
Okay, thank you, Paulo. And then also, yeah, I just want to also say about this base here. You should, once you, let's say, define the block size, then distribution points, then after that, you should type the base here. Because if you move on to the next stage, next optimization parameters tool, here, then that base, what we have here, and then what we have here under the distribution points, it would be used to calculate, for example, the search ellipsoid, the optimum parameters in terms of the search ellipse. Okay. Now what we can see here, the search distance as well. It says here for x directions. For the x directions, we can see that the highest value of the kriging efficiency represented is here. That means like from 60 up to 90, probably the best search ellipse should be used to achieve good quality of estimation. Okay, it's the same way. If I have a look here, I can see the slope of regression as well. Yeah, and also if I go back to kriging efficiency, but I would like to show you, this is for the well-informed area, moderate informed area, and then sparse area. Yeah. Then if I go now to order by x-axis, if I go to here, there's a minimum samples as well, which shows here the minimum number of samples should be 6. Yeah, it also represents here that 6. There's a minimum number of samples, of course, but if you put more samples, it would be not sometimes good, but it will be better in this case. Yeah, this is the idea about the QKNA analysis. You can generate all those graphs. Based on those graphs, you can define, let's say, optimal parameter of estimation statistically. Okay, this is quite important to say. Then after that, if I go to the next one, the estimation itself, if I go here, input models, I can put my block model. Let me say that this is OB mode, that one. Then output model, let me put here block model, let's say grade 1. Yeah, this is zone number 1. Then also there's good opportunity here to use dynamic anisotropy as well, if you need. Then after that, if I go to here, define estimation, here that I'm going to define the estimations. You can see here, I have my ordinary kriging estimation for gold and silver. Actually, it's a co-kriging method. Here I'm going to apply because I use the cross-variogram. But for copper, I'm going to use ordinary kriging, but univariate estimation. That means only one value, only copper. Okay. Then here you can see the parent cell estimation or subcell estimation. You can apply different methods as well here available. Then cell discretization points we can arrange here. The only one thing which is I think it's quite important to say here is if you can see here the output standard statistics. If I click here, output field, and you can see when I run estimation, the system automatically generates those attributes here. That means my kappa grade, kappa variance, number of samples, number of holes, and so weight of mean, and so like this. But if I go back to here, let me select gold. If I go select here, then if I click here, output all kriging statistics, the system automatically also calculates for you guys kriging efficiency, search volume, slope of regression, and then variance of Z, and those parameters. Yeah, and other parameters, summary of positive weights as well. All those parameters we usually actually to do that estimation, we usually run separately. And then, for example, for slope of regression, kriging efficiency, we have a process in a Studio RM, and then it's run separately to calculate them. Then after that, most of the people use those parameters to categorize their resources and to get the confidence of the estimation and so like this. Yeah, in this case, in the advanced geostats model, just selecting that options output all kriging statistics, the system automatically calculate for you. Okay. Then if you go to the review of the variograms, here we can see the variograms. We can assign the variograms for each interpolator, for example, gold and silver and copper. This is variogram number 1, variogram number 2. I can change as well. If I go to the search volume, of course, I can change my search volume as well. For example, for gold and silver, I'm going to use that huge search volume which came from my range, from my variograms. But if I need to change it, I can change it as well. For example, if I put here, let's say 60, I don't know, 50, and then here put, let's say 25. Then if I click here, the system automatically changed now here. Yeah, the same here, the sample number of limits. I'm going to say here that for that search ellipse, I'm going to run the primary ellipse. I'm going to use minimum number of samples is, let's say 6. The maximum number of samples I put here, let's say 15. And click apply. Yeah, and then if I want to add size factor, as we have in a Studio RM, I will put here, let's say, minimum number of samples 4, and then here 15, and then click add, and so on like this. I can edit my search volume factors here. Then after this, once you arrange all those parameters, you need to go to here, run estimation, and now this is the summary of your estimation: holes, input model, rock, your key field. Here the parameter files as well, all of them here, and then this is the summary. I'm going to use gold and silver using the co-Kriging method of interpolation. Here I'm going to use individual copper only univariate estimation. Yeah, then what I need to do, click run estimation. Yeah, it's done. Then after that, I'm going to just click display. Let me show the gold. Click display, and now we have a block model here. If I load like as a blocks, as now you can see the blocks. Yeah. The only one thing is also would like to say here as well. All those parameters, such as variogram file, search parameters, estimation parameters files, everything is saved here as well in your project files, and then it's suitable to use. For example, if you want to run, if you want to use those files in a schema process or estimate process in a Studio RM. And also another thing I would like to say here, when you're working here in the Advanced Geostats module, and then you can easily jump to the Studio RM. It's because it's available, for example, right? It's kind of work independently. You can load, you can see the visualization. Also, you can, if you need to run something, you can run as well. Yeah, it's work both way. Yeah, it doesn't mean that like if you work in Geostats mode, that means the rest of the comments here is blocked. It's not like this. You can run parallelly something as well here. This is actually, guys, this is what I wanted to show today. Yeah, and then this is my result of my block model. Hope it was clear and useful for you guys. And then, yeah, I just want to say that again, thank you very much for your time. Hope that webinar was useful for you. And then, yeah, see you next time. And then goodbye.
Thank you, guys. Bye-bye for now.